So let's again move to the what we have in the tool and parts. So as you see here, 8 register part 8 and offset by 30 mm, from x direction 30 and from y direction 30. And here program we have going from milling and drilling program. So we will use G92 code to shift the origin from machine origin to the top surface of the workpiece. So Z20 we will see. Let's move to the 8 register part 8. Let's see the what are the properties of part 8. Okay, so here part 8 mill workpiece part 8 100 size is 100 and 20. So just remember that. Okay, we can mark it size 100 and 20. Okay, then we are going to use tool number 3. So again we can write T3 specification. So again we will go and check in the inventory. So milling tool number 3, that is the mill diameter mill flat, end is flat, diameter 10, length 50. Okay, diameter 10, length 50. Okay, then we are also using T3 or T4 tool. Okay, T4 tool. So we can also mark T4. What is diameter? So from inventory we can check milling tool T4. You see, drill tool. Okay, T4, diameter 10, tip angle 102, length 50. Okay, tip angle 102, length 50. Drill tool, this one is drill tool, this one is mill. How we can differentiate mill and drill? Check here. Here tool name here and mill diameter. Okay, next tool name mill diameter, then tool name milling 1 flat and mill diameter, then tool name drill 1 and drill diameter. So it is drill tool. Okay, okay. So again I am going to hide the machine part, then turn on the feed for transfer limits. Okay, so as the program will execute, tool will be loaded. So G92 we will shift the origin. So let me execute one by one. Aluminum part should be aluminum. Okay, part is loaded. Next, origin shift now. As soon as I execute this command G92 syntax, origin will be shift from here to here. This size is Z20 and this distance is Y30. This distance is X30. That's why 30. Okay, and now we are going to shift the origin from here to here, programming origin. So coordinate is X30, Y30 and Z20. So we have to write G92 and these values. Okay, then we will set the tool number 3. Okay, now you see cross symbol here, it is appearing. So we, after this, the tool origin programming origin has been shifted here. Next, then tool is loaded. Okay, now see Z-5. Next is not Z-5, it is Z2. At this point this height is Z2 because this line has been executed. Okay, next G01, it was rapid transfer, then tool will go linear motion at the distance. At what distance? Z-5. It G20 total thickness of the work is 20, but z is equal to 0 here, so we can write z minus 5 downward direction. Okay, from here all the towards this side, bottom side is z negative, so tool will go only minus 5 distance, fit to 50 and spindle speed 3, m03 clockwise rotation. See, next command, we will take the tool to move along x-axis by 70 distance. Oh sorry, it is y70, it will move along this y70. Okay, then G02 circular interpolation, tool will move next coordinate value from here. This one is x15, it tool is at present position x15. Okay, and y70. Now I am going to take an arc, so counterclockwise clockwise, so G02. Okay, circular interpolation, so clockwise, so I have to move tool this way, so I will use G02 command. Then what is the target position of that arc or circular section? So that is x15, x30, somewhere here y85, so along x35 y85 it is y present, so we are going to make an arc that is that will start here and that will end at x30 and y85. So in that arc we are going to use 15 mm along increase in x direction and 15 mm along y direction, so radius should be 15 mm. So that's why we have to write x30 y85. Now as we know, this one is static location, this one is end location, so what is the direction of that arc and what is the radius, what should be the radius? So our radius should be some this 15, and what should be the center should be here, so that we can rotate it, so along this. Okay, so that's why you need to write I15. Okay, so if you write somehow I15 and J15, what will happen? Where will be the center? Here along x, it will x15 y j I15 and j15, so center will be here. Okay, so it will take different type of arc, and okay, so only x increase is there and you can complete that arc. Okay, next see this. Okay, then G01 y x85, it will move linearly. Next y15, so y15 will come this way. Then x15, so it will go here linearly. Okay, then we will take off the tool by z is equal to 2. See this. Next command will take off rapidly tool by 2 mm distance. Okay, this one from the top surface it is 2 mm away. Next we will change the tool will be changed by next command. Okay, next tool is G001, rapid position of the tool G00. We have changed the tool by T4 number. As you see the properties of tool 4, diameter 10, tip angle 102 degree and length 50. So tool number 4 is loaded, and we have set the tool at x30, y30 and z2, that is height of the tool at z2, position of x coordinate and y coordinate value is x30 and y30. Next now I am going to use again Kant cycle. So to write the Kant cycle, again G81 code you have to use. Then how much see this, what should be the depth of drill hole, so you have to write by that, because this one is out z0, so tool has to go 20 mm, so I will write minus z minus 20. R1 I will retrieve the tool, it is at present 2 mm, So but I will retrieve only 1 mm and it will move next coordinate position M03. I will turn on the M03 and then coolant M08, turn on the coolant M03, spindle start clockwise. Okay, then okay, this step has been completed. Now since it is scanned under the canned cycle, so tool will move only at the coordinate value, it will drill hole y70, then x70, then x30, y30. So tool will come here and drill hole. Then again x50, y50 somewhere here. Okay, so you can visualize M30. So we have completed. Okay, so I am hiding the tool holder and tool also and table also, so that you can take a look. Okay, as you know, it is angle tool having tip angle. It was not flat, that's why you are not seeing the complete hole, but here it is visible that you have drilled hole. Okay, 5 drilled hole, it is visible. Okay, what if, let me show you how much we have drilled. So I will cut off from right, see this, okay, okay, okay. So this is the way. Again we can check from the bottom also, or back, front. That is because it is having tip angle, so it is just touching the bottom surface. Okay, so as I have mentioned here, what will happen if I write Z15, Z minus 15? So it will drill, instead of drilling at the depth of 20 mm, okay, it will drill only at the distance of 15 mm. Okay, let me change. Stop, I will stop, then Z15. Okay, tool table, see this. Now you can check the height, that was somewhere here, now it is only 15 mm depth. Okay, and you can also check for 5 mm depth. Okay, you can increase the speed from here, you can slow down. See this, only 5 mm drill hole has been prepared. Okay, so I hope you have got the clear understanding. Okay, so once again I will hide the tool and write the command. Okay, no, I will hide the table and you will see transparent. Okay, transparent. I hope you have got the clear understanding how to use slot milling and as well as circular uh, milling, and then state, then how to use. As you see, I have not used G80 cycle. I have to write because my program is ending here, so it does not matter, but proper procedure is to write G80 cycle at the end of this one here. Okay, we can write also in small and capital. That is no, there is no effect on our programming. Okay. So move to the our original program and make it as a z minus 20. Okay, so I hope you got the clear understanding. Okay, thank you very much.